Good morning, students. Coordination compound, the class 6. Yesterday, we discussed the rules for naming cationic and anionic complex. Now, I am discussing the today valence bond theory. I am discussing valence bond theory. Valence bond theory. What is this valence bond theory? It is very important. So, according to valence bond theory, first I can discuss what assumption. I can discuss what assumption. So, what are the assumptions? So, this is the valence bond theory. So, the first I can discuss what assumption or postulates. So, the first assumption is central atom in a complex, central atom in a complex, central atom in a complex have have vacant, have what vacant or empty orbital, empty orbital, empty orbital for the formation of, for the formation of coordinate bond, formation of what coordinate bond with what, with a suitable ligand, with a suitable ligand. So this is what first point. The central atom in a complex have vacant or empty orbital for the formation of coordinate bond with ligand. This is the first assumption. The second is here. The second is here. The ligand have at least at least one orbital, at least one orbital containing what, lone pair of electron, lone pair of what electrons, lone pair of what electrons, lone pair of what electrons. So this is the second point. The next is here. The third point is here. Third point I can discuss here. Okay. So here, now I can do third point. So the orbital of what, metal atom. So orbital means atomic orbital of what, metal atom. So undergoes hybridization, undergoes hybridization to form so new hybrid orbitals, new hybrid orbitals, new hybrid orbitals with definite, with definite geometry, with what, definite geometry. This is the first point. The central atom in a complex have vacant or empty orbital for the formation of what, coordinate, formation of coordinate bond with ligand. And the second is what here, the ligand have at least one orbital containing what, lone pair of electrons. The third is the atomic orbital of what, metal atom undergoes what, hybridization to form a new hybrid orbital with a definite geometry. So this is first here. I can write here Sp3 hybridization. Suppose if it is a Sp3 hybridization, if it is a Sp3, what is the geometry? Geometry is what, tetrahedral. The geometry is what, tetrahedral. Suppose if it is a dsp2 hybridization, so it is a square planar, it is a square planar geometry. The next is what? D2sp3. D2sp3, or it is a sp3 D2 hybrid orbital. So it is called what? It is called what? Octahedral geometry. It is called what? Octahedral geometry. Very important. So the students, please go through all these points and you have to read. So according to valence bond theory, so shortly we can say what? VBT. So according to valence bond theory, the central atom in a complex have vacant or empty orbital for the formation of coordinate bond. What is it? Coordinate bond with ligand. The second point, the ligand have what? At least one orbital. So, for example, the ligand contains what? Donor atom. So, one orbital of a donor atom containing what? Lone pair of what? Electrons. So, the next is what here? The third point is here. So, the third point is here. I can write here. The third point, the atomic. Yes, anybody? The atomic orbital of water metal atom undergoes hybridization to form a new hybrid orbitals with what? Definite geometry. Suppose if it is sp3 hybridization, the geometry is what? Tetrahedral. Suppose if it is a dsp2 hybridization, so it is a square planar. And if it is a d2sp3 or sp3d2, so it is a octahedral geometry. It is what? Octahedral geometry. So this is what, this is the third assumption. So the now the fourth assumption here on I can write here. This is the third assumption is what? Now is the fourth assumption. So what is this fourth assumption? Yes, here what is this fourth assumption? So d orbitals. So d orbitals. So d orbitals undergoes what? Hybridization. Undergoes what? Hybridization. Undergoes what? Hybridization. Okay, hybridization. The d orbital, it undergoes what? Hybridization. So two types of hybridizations are there. N minus 1d hybridization. N minus 1d hybridization. N minus 1d hybridization. N minus 1d hybridization. So it is called what? N minus 1 dehybridization is called what? This type of complex is called what? Inner orbital complex. It is called what? Inner orbital complex. It is what? Inner orbital complex. This is inner orbital complex. And suppose if N dehybridization, if hybridization is of ND type, so is called what? Is called what? Outer orbital complex. Is called what? Outer orbital complex. Is called what? Outer orbital complex. Is it correct or not? Yes. So here we are discussing what? We are discussing about what? The postulates of what? VBT. We are discussing the postulates of VBT. The first postulate, the central atom in a complex have vacant or empty orbital for the formation of coordinate bond with ligand. The second is the ligand have at least one orbital containing lone pair of electron. And the third, the atomic orbital of what? Central atom so undergoes hybridization to form what? New hybrid orbital with definite geometry. sp3 hybridization, tetrahedral. So dsp2 hybridization, square planar. Next, D2sp3 or sp3d2 hybridization. So it is called what? Octahedral geometry. So the next fourth point is the d orbital, it undergoes what? Hybridization. Two types of hybridization it involves. N minus 1 d n minus 1 d type of hybridization is called inner orbital complex. So nd type of what? Hybridization is called what? Outer orbital complex. So now I can discuss here. The next is what? What is mean by this n minus 1d? So this is the n minus 1d means what? 3d orbital and 4s orbital and 4p. So the mixing of what? 3d, 4s and 4p, it gives what? It gives what? D2sp3 hybridization. If it is a D2sp3 hybridization, it is called what? It is called what? Inner orbital complex. It is called what? Inner orbital complex. The next I can go for here. Next, now I can take next is the okay. Now is 1,4s, 1,4s. Next, 3,4p, th 3,4p, and what? Next is what? And 2,4d and 2,4d hybridization. So it is called what? Sp3d2 hybridization. Sp3d2 hybridization. This Sp3d2 hybridization is called what? This Sp3d2 hybridization is called what? Outer orbital complex. Is called what? Outer orbital complex. So all of you listen here. So the first is what here? The first is what is meant by, suppose, so n minus 1d, n minus 1d type of hybridization. It is nothing but a d2sp3. It is what? D2sp3. It is called inner orbital complex. It is called what? Inner complex or inner orbital complex. If nd type of what hybridization, if nd type of what hybridization, so it is nothing but a sp3d2. It is what? Sp3d2. It is called what? It is called what? Outer complex. It is called what? Outer complex. Okay, so you know that. So already, so you see here all of you. So 5 points are there. The first is the central atom having empty or vacant orbital for the formation of covalent bond with ligand. The second point, the ligand have what? The orbital contains what? A lone pair of electron, and the atomic orbital, it undergoes hybridization. It gives what? Definite geometry. So d orbitals undergoes hybridization. N minus 1 d hybridization is called inner orbital complex. Nd hybridization is called what? Outer orbital complex. So in case of here, in case of n minus 1, n minus 1 means 2 3d orbital, 1 4s orbital, and 3 4p orbital. So when it undergoes hybridization, so it gives what? D2sp3. It gives what? D2sp3. So this is called what? This is called what? Inner orbital complex. And next, this is for example nd type of what? Nd type means what? 1 4s. This is what? 1 4s and what? 3 4p, and next is what? 2 4d. So orbitals undergoes what? Hybridization. It gives what? Sp3d2 hybridization. This Sp3d2 hybridization is called what? Is called what? Outer orbital complex. Is called what? Outer orbital complex. Is it correct or not? Yes. The last point is, the last point I can write here. The last point is what here? The next is what? So if complex contains, if complex contains, if complex contains, if complex contains unpaired electron, if complex contains unpaired electron, is called what? A paramagnetic. Is called what? A paramagnetic complex. It is a paramagnetic. So no unpaired electron, no unpaired electrons, no unpaired electron is called what? Is called what? Diamagnetic. Is called what? Diamagnetic. So all of you listen. So this is what postulates of what? VBT. So once again I will repeat, it is very important. So once again I can write. So this is the postulates of what? VBT. So postulates of what? VBT. Yes, what are the postulates of VBT? So once again you go through this one by one. Same I can discuss here. So here the first point is what? Anybody? This is the VBT. Valence bond theory. Next is what? Assumption. Next is what? Assumption. Is it correct or not? Assumption. So once again, what is this anybody? The central atom. The central atom in a complex. Central atom in a complex have vacant orbital. Have vacant orbital. Have what? Vacant orbital. Okay, vacant orbital. Vacant orbital. So vacant orbital. So central atom in a complex of vacant orbital for the formation of, for the formation of, for the formation of coordinate bond. For the formation of what? Coordinate bond with what? Ligand. With the ligand. This is the first point. Second point, I can write here. Second point, each ligand, each ligand have one orbital, each ligand have one orbital containing lone pair of electron. Lone pair of what? Electron. Once again I am rating, it is very important. Lone pair of electron. Third point is the atomic orbital. The atomic orbital of central atom, central atom, central atom, atomic or central atom on hybridization, on hybridization, on hybridization, on hybridization gives definite geometry, gives definite geometry, gives what? Definite geometry. Example, sp3 tetrahedral, sp3 tetrahedral, which is correct. Yes, dsp2, dsp2 square planar, dsp2 square planar. Okay, the next is what here? sp3d2, sp3d2 or t2sp3, it is what? Octahedral. This is what, everybody? Octahedral. This is what? Octahedral. Is it correct or not here? So here the next, the fourth point, once again I am writing. So this is the fourth point. Okay, so d orbital, d orbital involves involves n minus 1d hybridization, n minus 1d hybridization, n minus 1d hybridization is inner complex, inner complex. It is what? Inner complex, or it is nothing but a, it is nothing but a d2sp3 type of hybridization. Next is what? d orbital, d orbital involve, d orbital involves nd type of what? Hybridization is outer complex, is called what? Outer complex. That is nothing but a sp3d2. And the last one is, if complex contain, if complex ion or complex contain unpair electron, unpair of, unpair electron, unpair of what? Electrons, is what? Paramagnetic, is called what? Paramagnetic. Okay, so these are the important points of what? Important points of what? VBT. So what is this VBT? The examination, what is the VBT? The central atom in a complex have empty or vacant orbital for the formation of coordinate bond with ligand. So for example, so this is the central atom M, and this is what? Ligand. It gives what? Electron to what? Central metal atom. It forms what? Coordinate bond. And next, each ligand have one orbital containing what? Lone pair of electron. And next is what here? Next, the atomic orbital of central atom on hybridization gives what? Definite geometry. What is the geometry? sp3 is what? Tetrahedral. Next, dsp2 is called what? Square planar. Or sp3d2 or d2sp3 is called what? Octahedral. D orbitals involves n minus 1 d hybridization is inner complex if d2sp3 is a hybridization. It is inner orbital complex. D orbital involves what? Nd type of what? Hybridization is outer complex if it is a sp3d2 hybridization. If complex contains what? Unpair of electron is called what? Unpair of electron is called what? Paramagnetic. Is called what? Paramagnetic. So my dear students, it's very important postulates or assumption. First you have to go through it and you have to read. So after that I can discuss the four important example. So out of these four example, so as per the examination pattern, the one question is compulsory in the annual examination. Please go through this. Okay, over. Yes. Now I can discuss example. I can discuss example. First, you remember central atom having what? Vacant orbital. Central atom having what? Vacant orbital. And the ligands having what? Filled orbital. These on overlap. It forms what? Coordinate covalent bond. Yes. Coordinate covalent bond. Okay. The first example. I can discuss one by one. Yes, the first example I can discuss. Very important example. Yes, first I can discuss NiCl4. This is what? Minus 2. This is what? Minus 2. NiCl4 minus 2. This is the first examples based on what? PBT. Total 4 examples are there. So all are very important because one is compulsory for your examination. Yes, NiCl4. The first I can write here. The electronic configuration. Electronic configuration. The electronic configuration of nickel. The electronic configuration of nickel is in ground state. Is in ground state. The electronic configuration of nickel is in ground state is argon. It is 18 3d8 4s2. Argon 3d8 4s2. Okay, argon 3d8 4s2. Next, you don't know oxidation state of what? Nickel. You put X. And this is 4. How many chloride answer? 4. Charge is minus. What is the total charge? Minus 2. X is equals to what? X is equals to what? 2. X is equals to 2. Is it correct? You see, nickel oxidation state is X. The 4 ligands are there. So charge is minus 1. The total charge is minus 2. X is equals to 2. X equal to 2. X equal to 2 means what? It indicates oxidation state of what? Nickel. So I can write. So this is over. So I can write in +2 oxidation state. In +2 oxidation state. In +2 oxidation state. In +2 oxidation state. The electronic configuration. The electronic configuration. The electronic configuration of nickel is argon 3d8, not 4s2. Why not 4s2? In +2 oxidation state. This is what? +2 oxidation state. The electronic configuration of nickel is in ground state is argon 3d8 4s2. In +2 oxidation state, the electronic configuration of nickel is 3d8. So oxidation state of nickel is +2. +2 means what? You have to remove what? Electrons. So this is what? 3d8. Okay, this is the 3d8. So the next is what here? Okay, now I can write here. Okay. Yes. The next is what here? This is over. Now I can take argon. Yes, this is what? Argon. And I can write the orbitals. This is what? 3d. Next it is what? 4s. I can write what? 4s. Next is what? 4p. This is what? 4p. Is it correct or not? Yes. This is what? 4p. Is it correct or not? Yes. How many electrons in D? 8. 1 according to Ohm's rule. 1, 2, 3, 4, 5, 6, 7, and this one 8. Is it correct? Yes. Chloride is a weak ligand. If it is strong ligand, spin pairing takes place. Spin pairing means unpaired electron, they are forced to pair up. But here chloride is a weak ligand. Chloride is a weak ligand. Chloride is a weak ligand. No spin pairing. 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 Okay. So now no spin pairing. Okay. No spin pairing takes place. No spin pairing takes place. So now finally one 4s orbital and 3 3 4p orbital undergoes undergoes hybridization undergoes hybridization to form to form Sp3 hybridization undergoes hybridization to form Sp3 hybrid orbital Sp3 hybrid orbital Sp3 hybrid orbital. Is it correct or not? It forms Sp3 hybrid orbital. Okay, I can write here same organ. Okay, I can write here. This is the d orbital 1 2 3 4 5. Next it is what 4s. Next I can write what this is what 4p. This is what 4p. Yes, no 1 2 3 4 5 6 7 and 8. So what is this anybody? Chloride is a weak ligand. Chloride is a weak ligand. Next is what? No spin pairing. No spin pairing is takes place. No spin pairing means unpaired electron remains. There is no spin pairing. So finally one 4s. One 4s on how many p? 3 4p orbital undergoes hybridization to form sp3 hybrid orbital. It gives 4 equivalent hybrid orbitals. Okay, yes, this is what 3d. This is what will be 4s and next it is what 4p. So what it forms when it forms sp3 hybridization. It forms what? sp3 hybridization. It forms what? sp3 hybridization. Okay, it forms. Okay, this is what I can write here. This is what sp3 sp3 hybridization. Sp3 hybridization. Okay, the sp3 hybridization. Is it correct or not? Yes. All of you understand? Yes. So here what happens? So how many ligands are attached? The 4 ligands are attached. How many ligands are attached? 4 ligands are attached. So all the 4 ligands are monodentate ligand. So the one more VBT point, the last point, the half-filled orbital of what central atom overlap with what? A filled orbital of what ligand? It forms what? A coordinate covalent bond. It forms coordinate covalent bond. This is the first term. The next is what here? This is the sp3 orbital. So one 4s orbital and 3 4p orbital is on mixing. It gives a new set of hybrid orbitals that is called what? That is called sp3 hybridization. The last one is what here? The next is what? Organ. The next is organ. And now I can write it is the hybrid orbital. Yes. 1, 2, 3, 4, 5, 6, 7 and 8. This is a 7 and 8. Next is what? 4s. Next is what? This is 3d. And next it is what? 4s. Next is what? This is what? 4p. This is what? 4p. Okay. So 4p. This is what? sp3. This is what? sp3. Okay. This is what? sp3. So here all of this here. So next here, each orbital contains maximum of 2 electron. Each orbital contains maximum of 2 electron. Correct? So chloride is a monodentate ligand. It gives one pair. One pair means 2 electron. Chloride is a monodentate ligand. It gives one pair. One pair means 2 electron. So each orbital contains what? 2. First chloride gives 2 electron. Second chloride ligand gives 2 electron. Third chloride gives what? 2 electron. And the fourth chloride gives what? Gives what? 2 pairs of electrons. So this white arrow mark, it indicates the electrons of what? Nickel. And this the color arrow mark, it indicates the electrons of what? Ligand. So here now I can discuss it. These steps you have to write down. So lastly, finally, so I can write here. No, I can. What is the geometry? What is the hybridization? Yes, the question. Hybridization. Hybridization. Yes, hybridization. What is the hybridization? It is a sp3 hybridization. What is the name of hybridization? It is a sp3 hybridization. Hybridization is sp3. Hybridization is sp3. What is the geometry? What is the geometry? What is the geometry? Geometry is nothing but a tetrahedral. Geometry is nothing but a tetrahedral. Geometry is nothing but a tetrahedral. What is the magnetic property? Magnetic property. Magnetic property. What is this magnetic property? The magnetic property is what? Paramagnetic. Magnetic property is what? Paramagnetic. So this is a paramagnetic. This is very important question. This is very important question. So in the examination, so explain hybridization, geometry and magnetic property of what? NiCl4 minus is based on what? VBT. Based on what? VBT. It is based on what? VBT. Okay, based on VBT. The first is what? Which is the central atom? Nickel. The electronic configuration of nickel is in ground state is 3D8 4s2. It is what? 3D8 4s2. Yes. What is the oxidation state of nickel? What is the oxidation state of nickel? Oxidation state of nickel is +2. So in case of this +2 oxidation state, the electronic configuration of nickel is only 3D8 4s0. 4s0. Okay, next argon. First you write on 3d orbital, next 4s orbital, next 4p orbital. How many electrons in D? 8. According to Hund's rule, no pairing of electrons takes place until each orbital contains single electron. 1, 2, 3, 4, 5, 6, 7, 8. Now 4s is vacant orbital and 3, 4p orbitals are vacant. You know that the first point VBT, first point, the central atom, the central atom nickel have what? Empty or vacant orbital for the formation of coordinate bond with ligand. First point. What is the second point? The metal orbital, the atomic orbital of what? The central atom, it undergoes what? Hybridization. It gives a definite geometry. Sp3 hybridization. Next it is what? It is a tetrahedral. Okay, the last next point is the each ligand can contain what? The orbital having what? Lone pair of electrons. This color it indicates what? The ligand having lone pair of electron. What is the fourth point? What is the fourth point? So the d orbital it undergoes what? N minus 1d. N minus 1d hybridization is called what? Inner orbital complex, but I can discuss later. But next is what? The complex contains what? Unpaired electron. If the complex contains unpaired electron, it is called what? Paramagnetic. Why it is unpaired electron? So it contains how many unpaired electrons are there? So it contains 2 unpaired electron. These 2 are unpaired electron. So that's why this complex is said to be paramagnetic. This complex is said to be paramagnetic. Okay. The next is what here? So the next point is the last point is, so the central metal atom have vacant orbital is overlap with what? Overlap with what? The electrons of what? The electrons of what? Ligand, or the filled orbital of what? Ligand. It gives coordinate covalent bond. It gives what, anybody? It gives coordinate coordinate covalent bond. It gives coordinate covalent bond. It gives what? Coordinate covalent bond. When it gives coordinate bond, so the central atom overlap with the filled filled orbital of what? Filled orbital of what? Filled orbital of what? Ligand. Filled orbital of what? Ligand. So it gives what? It gives coordinate covalent bond. So student, it is a very important. So in the examination, 3 marks question it is. It is a 3 marks question. So explain hybridization, geometry and the magnetic property of what? NiCl4 minus 2. First you write down which is the central metal atom? Nickel. The electronic configuration of nickel is in ground state is argon 3D8 4s2. And what is the oxidation state of nickel? So already we have calculated +2. In +2 oxidation state, the electronic configuration of nickel is only 3D8. Next, you have to write down the 8 electrons in what? 3D. Next, this is what? 4s and this is what? 4p. And the next is what? See here, very important, very important. Cl is a weak ligand. In case of weak ligand, no electron pairing, no spin pairing takes place. So next is what? 1 4s and how many vacant orbitals are? Of 1 4s and 3 4p orbital undergoes what? Hybridization. It gives what? Sp3 type of what? Hybridization. So next, now this is the 3D. No spin pairing takes place. How many vacant orbital? 1, 2, 3, 4. These 4 vacant orbital overlaps with what? A field orbital of what ligand? How many ligands are there? 4. Each ligand can donate what? A pair of electron. A pair of electron means what? 2 electron. So 4 pair, 4 vacant orbital, 4 ligand. Each can donate what? A pair of electron. So this color arrow mark, it indicates the electrons of the ligand, and this white color arrow mark indicates the electrons of the nickel. So here the electrons of the nickels are unpaired. So that's why it is called what? Paramagnetic complex. And what is the geometry? Geometry is what? Tetrahedral. What is the hybridization? Hybridization is Sp3. In CET questions are the lead question. In NaCl4 2 minus, this is the central metal atom, nickel. What is the oxidation state of nickel? +2. One more question. Next, what type of hybridization in NaCl4 2 minus? One more question. What type of NaCl4? What type of hybridization in NaCl4 2 minus complex? So it is Sp3 hybridization. So what type of geometry in case of what NaCl4 2 minus? The geometry is what? Tetrahedral. Whether NaCl4 2 minus is a paramagnetic or diamagnetic? One more question. It is a paramagnetic because it contains what? Because it contains what? 2 unpaired electron. So in the examination, so for 3 marks, first you have to write down electronic configuration in ground state, then in the excited state. Next you have to show this orbital. Next, second step is whether the ligand is weak, no spin pairing. If ligand is strong, spin pairing is takes place. And next, how many vacant orbital? These vacant orbital is on hybridization, it gives what? A definite geometry. And next is what here? The vacant orbital is overlap with field orbital of what ligand? It gives what? Coordinate covalent bond. So this is very important. Total 4 examples are there, my dear student. So today I am discussing only one example. So tomorrow class I can discuss another 3 example. They are very important. Okay. So the next is this is very important question. Okay. Thank you.